For this example, we want to solve the initial value problem. dy dx is 3x squared plus cosine x over y to the fourth plus y, with y of 0 equals minus 3. So let's start by separating variables here. We see we have a bunch of y's on the bottom and x's on top, so it's fairly easy to separate this. We will get y to the fourth plus y dy equals 3x squared plus cosine of x dx. I can then integrate both sides. Y to the fifth over 5 plus y squared over 2 equals x cubed plus sine of x plus c. And as I can see right now, I have no chance of solving out for y. Right, with a y to the fifth term, there's no way I'm going to be able to solve out for what y is here. So I'm just going to leave it in this sort of form and use that to write out my solution. So I can just now at this point try to satisfy the initial condition and plug in y of 0 equals minus 3. So I want to plug in 0 for x and minus 3 for y to get that I want minus 3 to the fifth over 5 plus minus 3 squared over 2 equals 0 plus sine of 0 is 0 plus c. So that is my value of c. And that is, yes, fairly complicated. So I get that c here is going to be negative 243 over 5 plus 9 over 2. There's no point getting that any simpler because that's going to be a messy fraction anyway. And then I can write my solution, which is going to be y to the fifth over 5 plus y squared over 2 equals x cubed plus sine of x plus 9 halves minus 243 over 5. And you could put the x on the other side if you wanted to, but you can also just leave it in a form like this to get the solution for that initial value problem when you can't solve out for y no matter how much you try.